Very well. Awesome. So thank you so much for joining today. Thank you so much, everyone. We have James from Prism here today. So thank you so much for being here. Really appreciate having you join us to give a talk for the protocol study group. And yeah, we are now in the sixth week of the study group, and we are focusing in on consensus layer. And in this session specifically, we will talk about the validator client, the architecture of the client, which connects to the beacon node and actually does all the validator duties. And yeah, it's an honor to have James from Prism, who is a developer of the consensus client Prism, of focuses his work on the validator client there, to share the knowledge here. So yeah, thanks so much again for being here. I hope you're all ready. You can go ahead.
All right. Thanks, Mario. So for today's presentation on validator architecture, it's going to be more of like a software engineering perspective rather than protocol specific. So I'm going to walk through the Prism code base for the validator client and sort of show how our validator client was designed. That is to say, like Prism was the first consensus client, so some of the code base is a little old and definitely could optimizations could be found, but it should give you like a high level understanding of how the software sort of works and what's the purpose of the software. Um, and I'll sort of go through some visuals as well as some code examples of how it all works. All right. Just a quick introduction. I have my socials here. I've been on the Prism team for close to 4 years now. And in 2022, we got acquired by Offchain Labs, who are the developers of Arbitrum. When I joined the Prism team, I worked on the web UI. And so Prism was the first consensus client to actually give a UI for stakers and allow them to sort of manage their validator keys through this UI. And that's sort of my entryway into crypto. Previous to that, I worked at JP Morgan as a full stack engineer for close to 8 years. So working with Angular and Java, but on the Prism team, I've been working in Angular again for the web UI, and then Golang for the rest of the code. So let's go through like a refresher on like what the validator client is, because I feel like the validator term is sort of like it could mean a lot of different things. And so for the Ethereum node architecture, we have the validator client, the beacon node, and the execution node. And I feel like the term validator is sort of like overused because sometimes you're referring to the validator client, sometimes you're referring to the individual validators that you import into this client, and sometimes you mean the key stores that store the private keys of private and public keys of your validator. And so the validator client will import all of the validator key stores into this and then allow it to perform the duties of the protocol, to propose blocks, to attest, and so on. And so for this presentation, I believe the key purposes of the validator client are: one, to manage and use your validator key stores, where the JSON file that stores your private keys for your validator. You would use the deposit CLI to go get these, to generate these JSONs, and then you would use that with the deposit contract to actually go through the activation process. We're not going to go through that entire life cycle of a validator, but it's just to show sort of what this piece is. And then the manage and use piece of this is, can you import your key stores? Can you back them up? Can you add settings to the validator at a protocol level? So that's setting your fee recipient, that's adding your graffiti, and so on. And then also to provide some functions to actually use your key stores to sign different messages that's required by the protocol. And then, of course, you want to be able to remove your key stores from the validator and maybe migrate it to another validator client, as well as slashing protection. And I'm sure that I'm missing some things in this list, but we can all categorize that as managing and using your key stores. And of course, the second part of what this validator client software does is it allows your validators to perform the protocol duties. And to perform these duties, their API calls to the beacon node. And there is a beacon API where you would perform these duties. And we'll go through that. So just to reiterate, what I'll be going through is specific to the Prism validator client. The validator client architecture is not something in the specs. So the duties that it performs and some of the functions that it has are part of the consensus specs, but each validator client is sort of different across the client teams. And it might actually be something nice to do to try to like evaluate what are some of the differences and where some clients can sort of optimize. Like I said, Prism was the first one, so like some of the code base is pretty old, and I'm spending some more time of evaluating some key parts of the code base to see if there are improvements in readability or trying to resolve some edge cases with startup and things like that. Okay, let me see if I can zoom in here. This is a high-level view of the Prism architecture. We'll start from the top here. There's these two boxes, validator and external. This is just showing that the validator client, all of these things, all these boxes are part of the validator client. And then the things that fall in the external bucket is not part of the validator client software. So these are other services that it can connect to, including the beacon node. And I'm going to go through each of these components sort of individually at a high level. But for Prism, you can start with a prism.sh file, which is just like an easier way to access the Prism binaries for the validator client. So for Prism specifically, we have two separate binaries for the validator software and the beacon node software. Some other client teams just have one binary, and you can sort of turn it on in different modes. Maybe that's something that we'll do eventually, but right now they're separate binaries, and we sort of access the code through validator/main.go, and I'm going to go through it. It's a little hard to see here, but I'll go through that. And well, this is the entryway. You'll import the configs, you import your flag options into the system. We have the main validator client that orchestrates 3 different services. And so for our services, we have like a monitoring service for Prometheus. We have the validator service, which is the primary service that executes all the protocol duties. We have a RPC service, which is more like a representative of an API service. This hosts APIs that lets users talk to the validator client through REST APIs or gRPC. For the Prism code base, it was sort of developed before the Beacon APIs existed, which is all REST based. So we actually have 2 types of APIs in our system. We have a gRPC and we have REST. Yeah, so the gRPC, the RPC service hosts the key manager APIs. Those are the APIs that let external users sort of access the validator client, and it will then go tell the validator service, hey, go update these things. And we also have the wallet at the top here, which is what in Prism manages the keys. And the wallet concept is something that's sort of specific to Prism, but all clients have their way of managing the key stores. And so for Prism, it's this wallet, and then we have key manager inside of that. And these key managers, they can be local, so you can sort of store your keys where you're running the Prism validator, or you can have it connect remotely to something like Web3 Signer. And then to perform the actual protocol duties, it's just calling the Beacon API on the Beacon node. So that's sort of at a very high level what our validator client does. And we're going to go through each of these components individually. Okay, so let's start off here at the beginning, where we're just importing our configurations. That includes like the beacon chains configurations. There's different ones like mainnet, minimal, and we have end-to-end. And then we also have all these flags because the software runs as a command line interface. So you just provide all these flags and the validator client imports that. So what does that look like in terms of the code? Oh, I'll go ahead and open up this here. So it's a little easier to actually see. And this is all in Golang, so I apologize if it's not that familiar to everyone here, but it should be easy enough to read. We have the start node function. This lives in CMD validator main.go. Here, this is sort of our entry point into the Prism validator client. We have this instantiation of new validator client here, and then we just start it up. And so I'll sort of jump into what is happening in this. So for the Prism Validator client, we sort of have two different initialization modes. This eventually will become one to sort of make it more clear. But there is like a specific setting for if you're starting the validator client with web, with the website activated versus just using the CLI. We'll just go to the CLI to sort of show what that looks like. So when we're starting up, we're setting up some of these, some of the wallets, which in Prism again is to manage your validator keys. So it's sort of like a wrapper object that can interact with something remote or interact with something local, like your local directory where the keys are stored. And for Prism specifically, we actually take the keys from your key store and then put it into like a new key store that just contains all of the keys that you've imported. Initializing the database will hold information for slashing protection. So what your validators have done already, as well as some setting information that you can use to actually configure your validator, stuff like your graffiti, or like what address do you want your fees to go to if you're lucky enough to have your validator propose a block where those fees actually go. So some of the settings are stored in here. As long as you don't disable the monitoring, we have the Prometheus service. So we're registering the Prometheus service here. And then you can see register validator service, register RPC service. And when you start the validator client, it'll just sort of start all of the services on different threads, and then just monitor how those go. We'll go into the registered services now. So sort of what I just showed in the code base, 3 different services that we have. And these, again, just run on different threads, and they manage different types of work. The register validator service does all the protocol duties. Register RPC service, the RPC service does the APIs, and then we have the monitoring with Prometheus. So let's take a look at some of the service specifics. So in Go, this CLI context, this is what gives you access to the command line interface information. And so this is what's used to check if your flags are set or not. So you can see here is this flag, the interop validators for specifically interop mode, is this set? And then if it is set, then go set this configuration. And as we go down, it's sort of the same thing. Graffiti, go get your graffiti information. If you have a Web3 signer, then go get that information. Proposer settings, go get that information. And then it'll go initialize the service. And then all this information is provided. You got your database, your wallet, your API information, how you connect there. Uh, Web3 signer config, whether you're using the web UI, and then eventually you register the service. And this has an interface. So this inside of this, there's a start function, and it will actually run all of these processes. Let's go to the RPC service. That's like something pretty similar. You can see something very similar here. You can go get like an auth token that's used for the API endpoints, and it's again checking all the flags, whether or not these are set, and then eventually it'll go, you know, set all the fields for the RPC server to host all the API related items. Okay. So in the validator service, that performs most of the key roles of the protocol, and the most important function in this is this run function. So if I can copy this, let's just go to that. We have this run function, and this is the main function that will perform the protocol duties. And this first part that I'm going through is just initialization. So when the validator client starts up and the validator service starts up, what does this thing need to do? In initializing the validator, getting the head slot from the beacon node, updating the duties so that we have the information of what protocol duties that we have to actually perform. This is just some health check items. We have accounts changed, which is a channel to check whether or not you added or removed validator keys. We have the key manager, which actually gives you access to the keys themselves and performs the key related actions like signing. And then pushing proposer settings. So we won't talk about this for loop just yet. Pushing proposer settings will just tell the beacon node what are some of the settings that you have on your individual validators. Like what is your fee recipient address? Did someone raise their hand?
There is a question. I'm not sure if you want to take a pause for questions or we should leave it for later, whatever you prefer.
Sure. I guess we can take questions for what we have so far.
There's actually a request if you could zoom in, please.
Oh, zoom in here.
Yeah, perfect.
Thanks.
Okay.
Yeah, that's much better. Cool. And while we are at it, any questions so far? Anybody would like to ask Jim something? Feel free to raise your hand, speak up. Yeah, Shashwat?
Hello. Yeah, James, I wanted to ask that while we were setting up the database, while we were initializing it, like who is providing this database service? Like, is it the Prism client, or is it like or or is the data being stored in the protocol level?
This is just local. So this is just your own database. Um, this is not like the beacon state that's sort of like shared across uh, the system. This is just your like a normal database. We use BoltDB, um, and that just spins up locally, and you just store all of that data locally. I hope that
Okay.
answered it.
Thank you.
Any more questions? Or I'll keep going. Okay, I'll just keep going then.
Go ahead.
Oh yes.
Okay,
Yeah, if you want to ask.
can you hear me?
Yes.
Okay, yeah, you spoke about the validators client being able to um, generate validator specific messages and sign those messages
Mhm.
using validator's private key. Can you just go over it again with the
Sorry, could you repeat
examples?
that last part?
Yeah, you said the validator's client, it signs messages using the validator's private key. So
Yeah.
I don't know if you can just go through that over again. Just a quick one.
Oh, I haven't gotten to that yet. So I'll show like an example of performing one of these protocol duties when we get to that piece. So I'm showing the validator service initialization first, and then I'll show how the keys storage sort of works, and then I'll show how the duties are performed. So we'll get to there soon. Okay, so in terms of the validator service initialization, we go into this function here. And this is when the validator starts up. So when the validator starts up, you have functions like wait for chain start. And this is checking against the beacon node, like, hey, has the chain actually started for us to do what we need to do? Wait for key manager initialization. So checking your Prism wallet, hey, do I have my keys added there? Do I have any keys um, in that location? Waiting for the beacon node to sync, because we can't really perform any actions unless the beacon node and the blockchain is actually synced. And then the validator keys themselves, we have to wait for their activation. So only active validator keys can actually perform duties. Either they're like active or they're exiting, but in some kind of active state that can actually perform these duties. And that is related to the validator lifecycle. You have to go deposit, then you have to wait for the follow period, and then they have to be voted in, and then they'll get assigned this status. And then we have like a doppelganger check to see like, oh, did we already use this key somewhere else, as just protection from potential slashing. And in this slide, I'm sort of showing the wait for sync, we can go into that function. So what is this function actually doing? Oh, I went into the wrong one. That's for the mock. So we got to go to the real one, this one. Yes. So in this, we're just checking this node client, which is an access point to do API calls, either gRPC or REST, and based on the response of this, is it syncing? Otherwise, just pull against this API. So to sort of show that, let's go to this, and you can sort of see, oh, this is just a JSON REST handler. It's a GET request, like go get me some information from this endpoint, whether or not the node is syncing. And the big takeaway here is, all these requests and duties are API based, so they just use the beacon APIs to get this information and perform the needed tasks. So that's just to show briefly what validator initialization is. So once it goes through all of this, your validators are active. You know that the chain is synced. You know that you have like a good connection with your beacon node, and then it can move into the next piece to actually perform these duties. But before we go to that, let's try to understand a little bit more on how the keys are actually accessed, the wait for key manager initialization, and how keys are sort of managed and stored locally. So I'll go copy this. So again, in Prism, this is Prism specific. You have to create a Prism wallet before you can import keys into our system. And so we have this wallet object, and the wallet will have things like what is the directory of the wallet and where are the accounts saved locally. And because we have a lot of the different types of key managers, some are local and some are remote, we have a key manager kind. And then, of course, there's a password for the wallet to actually access the wallet. So when you start up the validator client, you're asked for this wallet password that allows the software to actually access the keys. Otherwise, it won't have access. So again, this is going back into the wait for key manager initialization, whether you have a wallet or not. And if you do have a wallet, go initialize my key manager. And what is the key manager capable of? So the key manager has several different interfaces which give it access to different functions that can utilize those key stores. So we have the public keys fetcher, which is just to get the public keys of the key stores that you've imported. We have the signer, which is actually signing some message. So this function will let you pass in some object, and then it'll sign it, and then it'll return you the signature. We have the key change subscriber, which is just to see if there's any changes with if you remove the keys or if you imported new keys. And then there's deleter, but there's all these interfaces that let you actually work with your key stores through this key manager. And again, the key store, it sort of just looks like this JSON file, but this is our Go representation of it. This should match with the JSON files that you get from the deposit CLI. And then let's go through this example for the local accounts. Sort of what this looks like. So this function just lets you go import a new account into our system. And then let's go to local. Yeah, you can see these are some of the steps that we have. Now, not every Validator client will do it this way. This is more or less specific to Prism, but it should give a good sense of how some of this is managed. So copy the in-memory key store, which is sort of all of the keys. Update the copied key stores with the new keys, and then save the updates to disk, and then reinitialize the account store, which allows everything else in the system to access those keys, and then return the status of whether or not this was successful. And it's just taking these key stores. It's just taking these key stores and then taking the passwords for your key stores and then adding it. And this is just in terms of local usage. Now you might be more like maybe your company is doing staking or something like that, in which case this isn't exactly safe, because whoever has access to your validator client software also has access to your key stores, which is probably not good. So in that case, we have the remote key manager, where instead of storing these key stores locally, you use this webhook to remotely sign those different requests. And let's go open this link. So this is our remote key manager, and it just follows the same interface as the other key manager, so it gives you access to all those functions. But in terms of the remote key manager, it will use, sorry, got to go find that function again. This get sign requests JSON. So instead of signing it locally, it will go create this request, and then it'll send that request to the remote signer. And this is to illustrate, like, these are the types of requests that you can get. And then all this is doing is it JSON marshals the request. So you get the request information, and then it's just mapping it to this Go representation of the JSON object. So this is just setting it to like a string. And then once it has this object, it does it will do an API request. Let's see, where is it? Oh, here. Sign. I'm going to the wrong one. Yes, sorry. So we got internal sign. And then you can see this request is just going to this request path. And then it's sort of your like standard post request to that remote signer to do those tasks. And that's sort of what it looks like to actually request something to be signed. But we'll go through like a case on an actual duty and where this signature is actually used. So now we went over wallets and key managers and sort of how those keys are stored. We'll jump back to that run function and go a little bit lower to show performing the duties. So we went over all this. Update duties, push proposer settings, and then we get into this big for loop. And this is where all of the tasks in Prism are done. In other clients, they might work slightly differently. Some might be subscribed to the events API from the beacon node, and then instead of having a for loop like this, they would be triggered via the events. Some other clients might separate the duties into their own individual services and sort of run that separately. Like they'll have like some proposer service and they'll have a attestation service. But for Prism, we just have this for loop. And this for loop, once you have your updated duties, there's this slot ticker here. So every slot, all of this stuff will run, and then internally it'll have some some checks whether or not it actually has to perform this or not. So like update duties is really only on the epoch start, or if you don't have any duties on your validator client already, which means you just started up. And if we go down here, this is where the important part is. So we get the roles for your validators at the particular slot, and then we perform these roles. So what does that look like? This is where all of the different validator protocol duties are performed. So the beacon node tells us, oh, these particular validators that you have these duties, and now at this particular time for this particular slot, you should perform this duty. And what I'll show is the proposed block as an example. And on this slide, it's just sort of showing the same stuff. So let's go back here and go through an example of proposed block. So the validator client signs the Randall reveal, go get me my graffiti information that I have locally, and then go request a beacon block using the Randall and my graffiti here. The beacon node will then go request the execution payload, which includes all the ETH1 block information. That's all your transaction information, all of those things. And then the execution client will return your payload. The beacon node receives that and then finishes building your block, and then retrieve the beacon block here. And this entire process that I'm showing here is for local block building, but you can also have like a remote block builder with MEV, and that would look slightly different than this, but instead of the execution client here, it would be like the remote builder. Once we receive the beacon block back, we use the validator key store to sign the beacon block. We check the database if there's any slashable offenses with this task, like did we already do this before? And then in Prism, we build this generic block type so that we can go propose the block and send it back to the beacon node, and then the beacon node will broadcast that block. And we can sort of see the same thing through the code. So we have the proposed block function, and that block, this function was called in the perform tasks. And you can sort of see, go like, hey, go sign the Randall, go get me my graffiti, go call the beacon node to get my beacon block based on this information. This is the request information. And then B is the returned response from the beacon block. And so we have this sort of wrapper here so that we can actually sign it. So we have WB here. We sign the block, get the signature, signing root, build the signed block, just wrapping it, check if there's any possible slashing offenses against what was saved in our database. Just wrap it in this generic assigned beacon block. And this statement is sort of specific to what happened after Deneb, because when you're proposing a block, you also need the blobs. So you got to go add the blobs to this as well. So this is just a task that we need to do here. And then once we have this wrapper object, this generic signed block, then we can actually propose the block. And then the proposed block is, again, just calling, like, it'll just go call the specific endpoint. I scroll down here. Yeah, so this endpoint is just a post request sending all of that block information. So that's just to show like what one of these tasks would look like. And we also mentioned the signing the block, which is sort of under the hood. It's just going to the key manager and then calling that sign function on this object. Okay, so there's two extra slides for just talking about some other features in our system. One is the key manager APIs, and you can go to it here. And we probably messed up on the naming here because it should just probably be called the Validator client APIs, but we called it the key manager APIs because that's the primary purpose of the APIs, to manage your keys. And it has all these API functions that you can call against your validator client to get information about your particular key. So you have your you can get your fee recipient, go get the gas limit, and the gas limit, this is specific to if you have like a builder setup, like a builder configuration, your graffiti, and then you can do the local key manager, like list all your keys, import new keys, delete keys, or have like a remote one where it's the same thing but for remote. And then we have the web UI. So for Prism, we actually have like a UI. It's sort of in frozen status right now. We were about to remove it because we didn't think people were using it, but I guess people are using it. So if you have an opinion on web UI, please feel free to reach out to me. We can figure out a path forward for this, whether or not we can actually simplify it and then just keep it or not. But the web UI, it's just through Angular, and then under the hood, it'll use a combination of the key manager APIs and some Prism specific APIs to actually manage your keys and get and collect information. So this is just stored through this function, initialize routes with web handler, and then this web handler. Let me zoom in. Oh, that's not it. That's the wrong one. I'm getting lost on this. Oh, the web handler is just here. And so it's just using the built Angular project and serving that. All right, and we are getting to our last slide here, which is just a review of the architecture and a reminder that it's really meant to do two tasks: manage or use your validator key stores, and then perform the validator protocol duties. And we walk through not like in great depth on all the intricacies of how certain duties are performed, or other considerations like this is the Genesis slot, so we have to do things slightly differently. But it provides like a higher up architectural view of how our software runs and how our software is designed. And this isn't something that is in the consensus specs. This is sort of up to the implementers to decide how you want to organize these things in the best way that your team can manage this. And in our case, this is sort of our initial design, and we'll keep iterating on it to see if certain things should be changed. And this is where the client teams have more flexibility on their own implementations. And this also allows the client teams to do things that are outside of the protocol per se. Things like adding the web UI and like a remote signer and other types of plugins. And maybe some teams will use it for other chains that might need other information, that needs the software to run in a different mode. But yeah, I think that's all I had for you guys today. If there's any questions, otherwise maybe I'll hand it back to Mario.
Yeah, thank you so much, James. Very well. Yeah, it was really great. Awesome. Yeah, thank you so much. I think we can, yeah, we have a ton of place for questions. So, folks, if you have any thoughts, any questions, feel free to raise your hand. Feel free to ask anything. Yeah, we get around 35 people during the talk, so I hope we can get some insightful questions. Yeah, feel free. Also, maybe if you have further questions about Prism, about Cosmos later in general, I think it's also a great opportunity. Yeah, Katya.
Hello, thank you. I wonder, where does the attestation magic happen?
Attestations are also in the perform duties. So if I can just go to that. So under validator client, runner.go. And then perform duties should be a little bit below here, or perform roles. So like submit attestation is here. We have submit aggregate and proof is here. And then in validator client test.go, we have submit attestation. Yeah.
Thank you.
Nope, no problem.
Yeah, awesome. Any more questions, folks? Anything? Yeah, Shane?
Hey, James. Yeah, I was thinking about how like EPBS, the instrument proposed builder separation, is going to try to replace MEV boost with like in protocol builder proposers. So will this change how validator clients interact with proposers currently, like how block production is coordinated? Yeah, basically, it's curious how like Prism is preparing for EPBS. What kind of refactoring might be needed between a validator client and Beacon node.
Yeah, there's a lot of changes. I guess I'm not totally familiar with the branch, but there is like a EPBS branch for Prism. I mean, POTAs and Terrence are some of the proposers of all this. So there's changes in like the timing, like in this submit attestation, I believe, like here we have wait 1/3 or valid block. So it's like waiting 1/3 into the slot. And so with EPBS, I believe some of this timing changes. So there would definitely be changes on some of these functions based on the hard fork that includes this. So there would be some like if statement here that's like say checking like is this the fork that is that includes EPBS, or is it before that and then do things differently there?
Backwards compatibility stuff. Got it.
Yeah.
Yeah. Thanks.
Yeah, very well. Any more questions? Feel free to ask, folks. Anything goes. Yeah, Lauren.
I want. So my question is, can a single VC be used across like a validator key? Can it be used across different clients? Say I've used it on Circle, can I use the same key on Reason?
Yeah, that's a good question. So for Prism specifically, we don't currently recommend using the Prism validator client with other clients in production just yet. It would be nice if others tried to test it out, but for Prism, because we were the first consensus client, our system was designed slightly differently, and we used gRPC, which the gRPC API calls are slightly different than the Beacon API calls. So we've done a lot of things to try to enable REST in our validator client. There's a flag that turns it on. So by default, it'll use gRPC. But that is still sort of going through like a testing phase. And there are still optimizations that we're doing to make it on par with our gRPC implementation. In fact, I have some open PRs right now to improve that, but it has to do with how some of the system caches things. Like one thing that's expensive is getting the validator's status. So, like, only if your validator is active can you perform this specific task. And not all of our code paths are optimized so that it uses the same validator status. Like sometimes it's like calling the beacon node to go get the statuses again when maybe it doesn't need to. So there are definitely improvements that we're working on. But it was all because of our migration process from gRPC to REST. But for some of the other clients, it should be able to run with a different validator client and different beacon node. So I think Lighthouse validator client with a Prism beacon node should be possible.
Okay, thank you very much for that. I think another question I will have is, can I use a single validator key that I've used on, say, on Prism? Can I use it on another client as well?
It's the same key store, so it's the same format. For Prism, because we store it in the Prism wallet, you just need to back it up, and then it'll return to the regular key store format that you can import into other clients. Yeah,
I
so
got it. Thank you very much.
Okay, awesome. Thank you, Glory. And do we have any more questions, any more thoughts for James? Yeah, Shane.
Yeah, I was curious if you could talk a bit about some of the incentives or potentials for slashing for a validator, just to go a bit more into like the economics of like why you would want to run one, or even like how you would be selected as being the guy to propose a block, things like that.
So I guess I haven't really prepared for like protocol specific questions, but the protocol itself will go select will select the validator, and like from the Prism client perspective, it's just getting the specific duties that the protocol selected on the beacon node side. So from the validator perspective, it doesn't know anything about uh, the incentives or anything like that. It's just being told like, hey, go, like, this is your task. Now go perform your duty. And like in the process of performing your duty, you would go call the beacon API for some more information. That's specific to your validator client. But in terms of the slashing component, your validator client, maybe you were like load balancing your system, and like you've collected some information locally and you've stored that in your database, and for some reason your validator, when you're calling the API, it's giving you back information to make your validator perform the same task again. And so in that case, you're checking the database, hey, like, did I already do this thing? And in terms of this, am I violating the protocol by performing this duty again? So for in terms of like protocol incentive stuff, the validator client tries to be dumb for the most part. Like I think for most, if not all, client teams, if it's not all, it should be all. The validator client should be sort of like dumb to the protocol design. It should just sort of call the beacon node, and the beacon node will determine all of those other things. The validator client will just give your keys access to performing that particular duty.
Got it. Just do your job. Separation of concerns between
Yeah, separation
beacon node and validator. Yep.
Right.
Yeah, awesome. Any more thoughts, questions, comments? Anyone? We still have some time to go, and 30 people here. So, oh, I just noticed the cat in the picture. It's so cute.
Thanks. I have
I
two
mean,
cats.
I mean, love the baby, of course, but like, you know, the bonus kitty is great. Yeah.
New dad and two cats.
Yeah. Any. Yeah, so maybe less technical question, like how are you handling being a core developer and a dad and a kid dad at the same time? Like from the perspective, what is it like comparing maybe to other more regular, corporate experience? Like, what is it like to be working in the Ethereum core? Yeah.
Oh yeah. That's a good question, because I came from JP Morgan, which is a very different culture than working in crypto. You sort of have to be a lot more independent. I think actually being core dev and being a dad is nicer, because core developers have a little bit more flexibility. It's totally remote in my case. So in terms of off-chain labs, there's employees across 19 countries, and we're only about like 100 people. So it's not a very big company. Prismatic Labs was even smaller. So like when I first joined as a Ethereum core developer, it was only on a team of 10 people. But I think it has given a lot more flexibility. And in terms of culture, I mean, it's a lot less meetings, which is always nice. You can focus a lot more on work. But I guess the skills that I learned in corporate sort of still apply. I mean, there's still politics in Ethereum core development, and there's those kinds of aspects that working at a big company sort of also teaches you. But for working in the Ethereum space, I guess it's a little bit more free. You have to sort of think on your feet, and uh, you're not in the bubble of just your own company. Like, you try to collaborate with people outside of the company. You work with people at the foundation. You work with other client teams that are at other companies. So that aspect's kind of cool.
Yeah, awesome. Thank you. Yeah, definitely. Like, it's very collaborative and open. So, we have Joshi. Yeah, go ahead.
Yeah, hi. Thanks for the talk, James. My question is also a little tangential, but I wanted to ask you what you think of the idea of the beam chain, specifically, like, as someone who's put so much like effort and love into working on the beacon chain.
Yeah. I don't think the beam chain like invalidates the current client teams. We're all invited to the beam chain calls, and I think it's important, especially down the road, that the beam chain is not just there to replace the current client teams, but sort of maybe add additionally to, because the beam chain client team members are usually like new individuals interested in Ethereum core development, and they come with a lot of great new experience, especially in the ZK space, which is great. But in terms of the consensus protocol itself, there's all these different little like exceptions that aren't specifically written down in the consensus specs that are implemented and sort of like learned over time on the current consensus teams, like things like the Genesis slot, like what do we do there? And like there are certain cases around how language specific systems will deal with errors slightly differently, which could result in a consensus failure. Things like in Golang, if I perform this specific function, it might throw an error. But from the spec perspective, you're supposed to no op that even if you receive that error. So like specific things like that is learned over time from the experience of the core developers that are working on the client teams right now. But I don't know. Overall, I'm bullish on this. It's always good to have people more interested in core development, even if it's like a different aspect of it. I think we're on like the third generation of core devs already. So there's been like a lot of predecessors that have worked on these client teams, and leadership within these client teams have sort of shifted over time too. And yeah, this succession plan for Ethereum implementers is important for the ecosystem.
Yeah, cool. Thanks for sharing.
Very well, yeah. Thank you so much. Yeah, we have a space for another question if anyone wants to ask. Otherwise, maybe we can wrap up here. But yeah, any more thoughts? Anyone? So, okay, yeah. One more question, Shashwat.
Yes, James. So trying to get into the repos of client of Prism, what could be like good onboarding strategies or the potential issues that the new onboarders might work on.
Yeah, I would say like most client teams were really short staffed, so it's hard for us to sort of handhold contributors, even though like sometimes we want to. The best contributions is usually like, oh, I've taken a look at this specific piece of code. This is why I think it's wrong. Creating a PR for that, adding unit tests for it, and then those are usually the PRs that get merged in through like external contributions. The main piece is again a lot of reading the code, looking at the specs again, and actually running the code to see if your hypothesis is correct or not. I think that's probably the best way to sort of onboard or contribute to the client teams. There's a lot of different ways to run the software now. So you can run it through kurtosis provided by the ETH Panda ops package. So you can actually like make changes to the code, rebuild the image, and then run through kurtosis, and you can actually check the logs to see if that's working the way that you think it is. And if you don't think it's working correctly, that's where we could probably like collaborate more, as well as Prism has like end-to-end tests. So you can do like a specific Bazel run, and it'll run this. It'll run Prism in interop mode, and run all these different evaluators. So adding new tests there, and yeah, that would be super helpful.
Cool. Thank you, James.
Okay. Yeah, thank you so much. I think we can wrap it up here, guys. It's been a while, and yeah. I don't want to keep you longer from your kids and cats, James. Yeah, I just see the picture there. Man, yeah, I appreciate it so much. Thank you so much for your talk again. It was really amazing. Yeah, I learned a lot. I believe we learned a lot today. So, yeah, really appreciate your time. I appreciate the lecture, and it's been great having you around. Yeah, thank you so much.
Did we have someone else ask something?
People are clapping. Maybe if anyone wants to comment, feel free. We still have. Anyone wants to have any question?
Okay, maybe not.
Okay, so or was it just the clap or? Yeah, sometimes people trying to clap raise their hand, but yeah.
Awesome. Well,
Anyway.
thank you, everyone.
Yeah, awesome. Thank you so much as well, James. Yeah, it was amazing. Appreciate it.